This video is just going to review a couple of basics about the arithmetic involved in our current system, the Hindu-Arabic system. So before you come to class, there are a couple things that I think would be beneficial for us to review. First is how are powers evaluated, how are numbers written in expanded form, how are expanded numbers simplified, and how does carrying and borrowing work in expanded form. So just a short review of powers. Remember that if we have 10 to the third power, that does not mean 10 times 3. It means that we have 10 multiplied by itself 3 times. The 10 is what we refer to as the base. And the 3 is the number that we refer to as the power, and it also is referred to sometimes as an exponent. So expanded form allows us to see the value of the digit in the position that it's in. So if we have the number 843, we're going to say that the 8 is in the 100s place, the 4 is actually sitting in the 10s place, and the 3 is actually sitting in the 1s place. And if we put that in expanded form, we're going to write 100 and 10 and 1 using exponents. So if we write each of the following in expanded form, if I have 84, then that 8 is in the 10s place, and the 4 is in the 1s place. If we have 352, then the 3 is in the hundreds place, so I'm going to write that as 10 squared. The 5 is in the 1s place, I'm going to write that as 10 to the first, and the 2 is in the 1s place, so I'm going to write that as 10 to the 0. And finally, if we have 9,446, that 9 is in the thousands place, which is 10 to the third. The first 4 that we see here is in the hundreds place, so that's 10 to the second. The next 4 that we see there is in the tens place, which is 10 to the first. And the 6 is in the ones place, which is 10 to the 0. So I'm also going to expect you to be able to work backwards. So I'm going to give you something that's written in expanded form and expect that you can write that as a number. So you can see here 4 times 10 to the third I've put as 4,000, 3 times 10 to the second is 300, 8 times 10 to the first is 80, and then I don't have anything in the ones place. So when we simplify that, it becomes 4,380. So let's look at 2 together. If I've got 8 times 10 to the second, that's 800. 2 times 10 to the first is 20. And then nothing in the ones place. So here we have 820. The next one is a lot bigger of a number. So looking at this, we have 5 times 100,000, because that's 10 to the fifth. We don't have any 10,000s, that's why there's a 0 there. We've got 3 times 1,000, 5 times 100, 6 times 10, and then 8 in the ones place. So altogether, we have 500,000 plus 3,000 plus 500 plus 60 plus 8, or 503,568. So when you're in expanded form, it allows us to see why some of our math rules work for adding and subtracting. So remember that if we're using expanded form, only single digits can be used as the number being multiplied by the power of 10. And that's the key thing to remember as we do the next few problems. So if we look at 23 plus 64, and we write 23 in expanded form as 2 times 10 to the first and 3 times 10 to the 0. And if we write 64 as 6 times 10 to the first and 4 times 10 to the 0, when we go to add, our place values are going to stay. And then I've got 7 sitting in the 10 to the 0 place and 8 sitting in the 10s to the 1s place, which gives us 87. So I want you to think back to that Chinese system that we looked at that was multiplicative. And remember, we talked that we don't actually show what we've multiplied by. Our place value does that, but we certainly could. So this is sort of our way of using that multiplicative system in our own number system. So look what happens in this next problem. We've taken 75 and written that in expanded form, and we've done the same thing with 48. So then when we keep our place value the same, I end up with 13 in the 10 to the 0 spot and 11 in the 10 to the first spot. But the problem is, if you remember just on the previous slide, we said we can't have double digits. Only single digits are allowed. So we're going to break down that 13 so that it's 1 times 10 to the first and 3 times 10 to the 0, which is what you're doing when you carry. So we have a 3 times 10 to the 0 that's left, and we take that and we're carrying that over into the left-hand column. That then gives us 12 10 to the firsts, but 12 times 10 to the first can't stay as 12 because that's 2 digits. So we'll break that down into a 10 times 10 to the first and a 2 times 10 to the first, which is 1 times 10 squared and a 2 times 10 to the first. So this gives us our final answer. Kind of complicated when we look at it in the multiplicative form. Some people even find it easier just to do the carrying and then make sense of the expanded form once the carrying is done. Let's see what happens with subtraction. So here, when I go to do the subtraction problem, I can't take 6 from 4, so we have to borrow. Let's look at what happens in expanded form when we have to borrow. So we know that we can't take a 6 from a 4. So I'm going to borrow from the next position over, and I'm going to take one of those 10s and give it to the 4. So now I've got 14 times 10 to the first that's sitting there. And now I can go ahead and do that subtraction. So I end up with 8 times 10 to the 0. And then when I go to do the subtraction in the next spot, I run into the same problem. I can't take 8 from 5. So I'm going to borrow and make that a 2, and I'm going to give to the next column over. So that's going to become a 15 times 10 to the first, which I can then subtract to get my 7, and then I'll subtract to get my 1. So a little bit easier to see in expanded form the borrowing that's taking place. So here's what I want you to do. I want you to bring this to class on Thursday as an entrance ticket. I want you to do the addition problem and the subtraction problem that you see here, but I want you to do it in expanded form like we've just practiced. This may be a little difficult, but I don't want you to stress too much. Let's just see what you can do. And it's going to be the first 2 problems that we do together in class. So make sure you have that with you. Make sure you give it some practice, and then hopefully when we do it together in class, it'll make it that much easier.